while we're having this conversation, if you would, please turn to page 177 in your books. Okay? Now, here's the conversation we're going to have. Just got it. We need reality, okay? And don't worry. We are scheduled. Even if we had a snow day or two, we still have time to finish the semester. Now, I know that there's that one teacher who's like, oh, crud, we have 2 chapters covered in 3 weeks, and all of a sudden they're going to super saturate you. You know the teacher? Yeah. That's not us. Okay? We planned accordingly, which is good.
Good, very good.
I never liked that teacher when you show up the day after Thanksgiving, the first day back after Thanksgiving, you're like, oh man, still turkey at home, can't wait. Okay, I get it. And then you get that one teacher who's like, okay, you're going to have about 3 hours of homework a night from here to the end of the semester just for my class alone. You're like, dude, I don't like this teacher. So, but we're going to do just fine, okay? So, here is the nice thing. This assignment that, I have a lecture that comes with today. You still with me? But this assignment will be due at the end of the period tomorrow. This opens up that time slot for the teacher who didn't prepare well. Okay? Does that make sense? We're good? All right. So please get to page 177.
But also, as a reminder, we only technically have, 3 weeks, 4 weeks?
3 weeks and 1 day.
So, if you do have a lot of missing work, we still will accept it. But here's the thing, that's something to keep in mind, right? I would hate to see you guys all panicking in finals week if you have a ton of missing stuff. But luckily with this class, we're very nice, we'll still accept it for full credit. Now maybe quarter 1, if it's like the first assignment we gave.
I'll still take it. Okay. I'll take it.
Never mind.
Yeah. No, I mean, it's a 4-point assignment. If a 4-point assignment is going to make the difference, I'll take it.
Yeah.
Deal?
So that's something just to keep in mind. We do only have 3 more weeks left.
So
okay.
Those weeks,
Makes
it's gonna
sense.
be like a big test with like things that we've done
Since
like
August.
How many questions?
255,312.
Is it like
Okay, I'll shorten it.
Depends. If you can make it.
It's worth 20% or 15% of your overall grade.
Monday, Tuesday, Wednesday.
But we're going to prepare you for it.
Okay.
We're not going to be like, you're not going to walk in here going, what was your way, what?
Okay.
Okay? Well, we got you covered.
I don't think you have to do it that way. Yeah. I think they just put it down.
All right, so just a little in the future to think about. So we have this week, next week, and the following week, okay, of regular classes. The following week after that, of course, they haven't told us this yet, but it shows on the calendar that the Monday, the Tuesday, and the Wednesday, right before winter break, is when we do our finals. It used to be Tuesday, Wednesday, Thursday, but now Monday was like Land of Make-Believe Day. But it doesn't sound like we're doing that. But they haven't told us, but it's on the calendar. It sounds like Monday, Tuesday, Wednesday, it's finals. So this is how, just so you know, because a lot of you, this is your first time in a high school experience. When we have our final, and I don't know our final will either be on a Monday, a Tuesday, or a Wednesday. I'm not sure which one it'll be.
It's not every day.
No, just one of those days. Like the Monday, you would have 3 class periods to go to, and we have them for like 90 minutes.
We have it Wednesday.
Wednesday?
1, 2, 3, 3 to 5 on Wednesday.
Oh, okay.
Because I literally have no finals. All my finals till Wednesday. I'm like, great.
Yeah.
And it's the last day.
Yeah, so like literally that finals week, like you would go to this class and then probably 2 other classes and no other classes. They're only 90 minutes in length. You're out of here like at 12:30 on 2 of the days, and then out of here like 11 on the last day. Something like that? Huh? It's very possible. You might have your 2 off periods might be a day that you might have to show up late, not show up at all. I mean,
like for example, Wednesday, I think it's 3 and 5. Sadly, you do have Oxford, but say you did have 3 and 5 off, like you had lunch 5th period and you had 3rd off. You don't.
You're sleeping in. You're watching Price is Right.
They posted it.
Oh, cool. So here,
Monday is 2, 5, and 6.
Monday,
Changed it
2,
again?
5, 6.
Yeah.
Two-
Tuesday is 1, 4, 8.
Okay.
Thursday or Wednesday is 3, 7, and then
And then,
Thursday is prep and assembly, makeup exams, and student conferences.
okay, so we are this is third period, yes?
Yeah.
So the first final on Wednesday would be this final. Okay, so meaning you would not have this class that Monday and Tuesday, you would come in on Wednesday.
But are they back to back, or do you have to wait till 7th? Some of them are back to back here.
Yeah, well, you got like 10 minutes in between. It's a longer 15 minutes. Yeah.
Oh, I have all my exams back to back this year. Okay, that's okay. Yeah, I see that. It pops up when you go onto the district page.
Cool. All right. With that known,
There will be no school May 24th. Oh yeah, we have this.
we're in third period.
You're in the
Looking at you.
None of the all the prep exams, so every day the exams start at like 9:15. Oh, so this is the first one? Yeah, 8:20 and 9:05 is prep time.
Tuesday, 148.
Oh, so I'll have to be the first period.
Sweet. And then go home, go have big old lunch, go to Pancake House, have pancakes, bacon, good stuff. All right. My friends, are we on page 177? Because this week, this is what we have planned. We have Monday and Tuesday that are just regular class. Wednesday, I will give you the take-home test. Still following me on this?
Yeah.
Thursday, we will make sure we cover the take-home test. Make sure that it's completely ready to rock and roll. Friday, we have the test.
Great.
And guess what you get to use on the test?
Take home test.
Yeah. So who's going to be the smart one that's like, I didn't do any of the take-home tests because it didn't mean anything to me? Good. Yeah. Don't be that kid.
I'm going to ask them.
All right. So, hey, we've been dealing with straight lines, yes? We've been graphing them. We've been finding the equations to them. Right? Okay. So let's kind of start applying this. I think this looks like it says car price depending on, I guess, the age of the car. So it looks like at 0 years you have the highest, and these are old figures. Let's just pretend we're back in 1970. But like if a car is 10 years old, it loses value.
Yeah.
So this is a scatter plot. Do you agree? So I know in science, they have you do something called a line of best fit. Agree? And a line of best fit is sometimes a tougher thing to do. And don't draw this in. Don't draw any of these in. But you'll have kids that are like line of best fit, line of best fit, line of best fit. You have one kid draws a vertical line of best fit this way. You're like, what's the best line of best fit to do? Well, in the world of data and statistics, a line of best fit is a line that would fit the nicest, that would have the same amount of points above the line and the same amount of points below the line. Let's think about that for a second. Now, did I draw the most ideal line of best fit? I bet you there might be one that's a little bit better, right?
Mm-hmm.
But I'm kind of like a human, so I might make a mistake. Agree?
Yeah.
I make mistakes. Y'all don't, but I do. Okay? But, so let's just pretend that Stirrup drew the most ideal line of best fit. Like I could make this y equals mx plus b, right? There's some sort of linear equation. So what could you tell me about the slope of this line? You don't have to give me the exact slope, but what would the slope be? Would it be positive or negative? Negative. As I go to the right, it goes down. So right now, I could be pretty okay saying, hey, I have a negative slope. Agree?
Yes.
Okay. That right there is my B value, my y-intercept. So it looks like on my thing, if I had to estimate it, I would say it's about 9,500. Okay. And I have a certain slope, so I'd have to figure out, from here to here. Oops, go away. From here to here, or from here to here, or from here to here. Somehow get a slope. Somehow figure out a slope. I have something that I probably have to do to find the slope. So far, I feel good that I have a negative slope. My line of best fit appears to be about 9,500. Okay. Well, it looks like on my line of best fit, it's hitting the y-intercept between 9,000 and 10,000. And between 9,000 and 10,000 is about 9,500.
Oh, okay.
Now, but here's the hard thing. Okay, so I got a flat digital screen I wrote on with a straight edge. You're going to hide your phone underneath your thing because you don't want to put it in the packet. You still follow me on this?
No.
The packet.
In the little pockets?
Oh, I think it's packet.
Literally.
So you have your book, and underneath your book you have your earbuds as well as your phone to hide. So now it's not sitting on a good surface, right?
Yeah.
So now you draw this line of best fit, and your line of best fit by you kind of looks like this. That's my line of best fit. Okay, one, that's not a line. And then you're going to also get the one kid who's like, dude, dot to dot. Yeah, this is how it works. It's doing this. It looks like, like in the emergency room, what your heart does. Okay, that's wrong as well. You want a line. You want to make a straight line. You want something that's going to fit your data nicely on a straight line. Now, data does not have to fall on a straight line, but for now it will. So far on this, I just want us to feel comfortable saying, can we draw some sort of line of best fit? Okay, I'd say use the edge of your ID as a straight edge. I want you to be able to look at data and say, yeah, the slope would be negative. I don't know exactly what the slope is, but I know the slope's going to be negative. And then perhaps maybe you would be able to look at where the y-intercept would exist. Does this seem okay so far? Any questions about this? Okay. Let's see. We'll get the one that goes this way. All right. Go ahead.
So here's my question. Is an estimate a true, is an estimate like an exact answer?
No.
No. So with these type of graphs, are you going to be getting an exact answer or an estimate? Estimate, okay? So keep that in mind because there's a difference between getting an exact slope and getting an estimate, okay? That's just something because I always get those two.
Yeah.
I did it.
Me too. All right. Hey, here's some more data. This looks like it talks about the size of a carrot. Oh, wait, must be diamonds. And then the price. The bigger the diamond, more expensive. Now, there's other things that go into the price of a diamond. You have a really big diamond that's like totally cloudy. That doesn't cost as much as a small diamond that's totally clear. But we're not worried about it. So they're just saying this. Let's see. Let's see if I can make myself a line of best fit. Let's do the green. I don't know. Does that look okay? Maybe I should change that color. Color should change a little bit. Let's change that to purple. Does that seem like an okay line of best fit? I mean, it goes amongst my data. I have some data points above. I have some data points below. I have some exactly on it. So let's think about this. if I extended this, we have the y-intercept that seems to be negative. Okay? Because it's like way down here. Seems like a negative value. I don't know exactly what the y-intercept is, but it seems with my line of best fit, it seems like it's a negative number. Can we cross the y-axis at a negative number? Yeah, sure. What do you think about the slope here? Is it positive, negative? Is going up? So going up is positive. So the higher the price, the bigger the diamond. Seem about right? I don't know why. So this is the size of Karis, and this is like if we're predicting the cost of a car. So this is kind of obsolete. I don't know if that's on yours. Okay. So far I've just asked you to be able to tell me if the slope is a positive slope or a negative slope. And try and give me an estimate on the y-intercept. Seem all right? Okay. All right. Okay. So slope is rise over run. That might have been a term you heard. It's y2 minus y1 over x2 minus x1, right? Do you agree with this? Slope can be positive, negative, 0, and undefined. Okay, so an example of a positive slope would look like this. An example of a negative slope would look like this. Example of a 0 slope is just a horizontal line, and an undefined slope is a vertical line. Okay, we're probably not going to, with data, look at these too much. I mean, they can exist, but we're not going to look at them too much. The y-intercept is our b value. So remember when I said the y-intercept is a point, so we write 0, comma b? Okay. All right. X-intercept. This is where it crosses x-axis. So this is going to be blank, comma 0. Is that okay? All right. But there's something that I haven't talked about on this yet. Slope we've seen. We've talked about. Y-intercept. The x-intercept we've used when we're doing the cover method of graphing, right?
Yeah.
Remember the 0, comma blank, blank, comma 0? This is the blank, comma 0. But there's something new that's called correlation. And it's from -1 to +1. Okay. This is really good. Negative slope. This is really good. Positive slope. Okay, so there's a low value and a high value. A low value of -1, a high value of 1. But the closer I get to +1 means the better my data fits to the line of best fit. The closer I get to -1, the better my data fits to my line of best fit. The -1 just means I have a negative slope. The +1 means I have a positive slope. So if I had a correlation that's close to 0, that's really bad. Okay? All right. Let me see what else you got on there. All right. So, my friends, I'm going to go 2 different ways. I'm going to use something called Desmos for right now, just to show you how things work out. Oh, my book. I need to get my book. Oh, I appreciate it. All right, so slope, y-intercept, x-intercept, correlation. If it's close to -1, that's a really good line of best fit with a negative slope. Positive one is a really good with a positive slope. Okay. All right, so let's see if we can figure this out. All right. So this talks about the table in time and days after December 21st, 2009, the snowpack at tree line of Wyoming Peak, which is one of our big mountains, right? So day 0, so day 0 is December 21st. 10 days later is December 31st. 10 days after that is January 10th, January 20th, 30th, February 10th, or February 9th, because there's, and then says snowpack in inches. 30 starts out with 35 inches, and it looks like it goes up. All right, so some things that we need to know. These are the X values. So these are X values. So my independent is time. And we're saying time and days. The dependent are the Y values. So this is snow depth in inches. Okay? Good so far? Now what we're going to do, we know that winter doesn't last forever. We have changes of seasons. But we might be able to possibly make some predictions based on what we know. Okay, so that's the first 2 things. All right. So the next, we have this line of best fit. Oops, go back. I gotta take this off because it's gonna goof me up. Come on, baby. Stay there. Extend. All right. Days, snow, depth, inches. Okay, we said the independent is the X, which is days. The dependent is the Y, which is snowpack and depth. So notice we have labeled our line of best fit. Okay? So December 21st is right here. And we're just going to call that 0. How many days do we deal with on this?
178.
178. Yeah, it looks like 50 days. So hang on. So I got 1, 2, 3. So hang on. We have 50 days. Does everyone see where I got 50, where we saw 50 days? Okay. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I can't, my grid isn't big enough to label out 50 days. I only have 20 dots. So maybe if we count by 2s, that gets us to 40. That doesn't get us quite to 50. Can I do 3s?
Yeah.
Hang on.
Let's go.
So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 53, or 54, excuse me, 57, and 60. Hey, is that labeled enough for our time and days? I mean, we go out to 50, and I realize 50 isn't on that, but we could figure out about where 50 would be in the X direction. Do you agree?
Yeah.
Hey, how deep's our snow? It goes from 35 all the way to 130, right? So if I started at 0, and let's see, I bet you we have about 20 things there. So I'm talking about 130 divided by 20, so 13 over 2. I'm just trying to figure out what to count by. That's like 7. Count by 6s? Did 6 get us there?
Oh, no.
See, that's 120. Count by 7s. 10s? Okay, let's do by 10s. That's nice. So I got 10, 20, 30, 40, 50. Oh, so I go from counting by 10s to counting by 5s because I'm off. Because I make mistakes. Do you feel comfortable that it would fit all of our Y data? Hey, notice I started at 0 both times. Well, there here. Okay. All right. Let's plot our points. Let's plot our points. So at day 0, that should have been day 0. Day 0, which is December 21st, right? We have 35 inches. Is that okay? And then at day 10, well, I don't have exactly 10, so I have to estimate it about right there. Day 10, I'm at 52 inches. So I'm estimating it's about right there. Okay. Hey, just looking at those 2 points, what kind of slope does this appear to have? A rising, which is positive. Okay. At day 20, which is about here, we're at 78 inches, which is like there. Okay. At day 30, oh, good, we have a 30. We're at 92 inches. At day 40, is about there. We're at 112 inches. And at day 50, out there, we're at 130 inches. Right there. Cool. So that's what my data shows from the snow levels. Does that seem like a okay line of best fit? So things that we definitely know. So let's see. What is the independent variable? What is the dependent variable? Plot the points on the graph below. Choose the appropriate scale and label each axis. Then draw the line of best fit. Have we done all that? When the equation, write the equation of the line of best fit. What 2 points would you use? Okay, our 2 points that we have to use have to come from our data. Agree? If it has to come from our data, that means they are the points on there. Anyone want to take a shot at one of the points that looks like it'd be pretty good to use? I think this is a pretty good point. What's special about that point? Which is then what? Which is then what? What part of y equals mx plus b? It's a y-intercept, it's b. So this also might be a pretty good data point. Okay? So when you're picking data points, you don't want to pick them right next to each other. You want them as spread out as possible, but as close to the line of best fit that you drew as possible. So I'm going to pick those 2 points. Does that seem okay? So I have the first and the second to the last. Okay. So I have the first, which is this, 0, 35, and the 40, 112. Okay. Well, we got lucky because we had the y-intercept that just existed on our graph. Agree? But so I'm going to treat these just like we would. So I want to find the slope first. So the slope is this. Is that okay? I'm going to label this x1 and y1 and x2 and y2. Do you still feel comfortable with what I've done? So then I'm going to take those values that I just marked and I'm going to plug them in. So I get 112 minus 35 and then 40 minus 0. Let's see, 112 minus 35. I don't know. I can't really do that in my head. So I'm going to do it off to the side. So I'm going to borrow, make that 10. That's 12. That's 7. 77. Ooh, okay. 77 over 40. This is my slope. Okay.
Wait, how did you get the 2 points on the top?
Oh, so what I did, I looked at my data, and I wanted to find 2 points that were far enough from each other, but were both really close to being on the line that I drew. So I picked the first point and the 5th point.
So you want them to be decently far?
Yeah, you want. That's true. That means everyone's going to have a slightly different answer, right? But don't worry. We're going to have Desmos save us here in probably tomorrow. Okay. So did everyone feel comfortable with what we've done so far? Now, 77/40 is a really ugly slope. Do you agree? Now, what I would say, do I know my B value? Yeah, it happens to be 35. Agree? So if I use y equals mx plus b, I can just say this. And that now I didn't really have to worry about the fraction. Agree? Okay. That's stuff we've done. Now, I'm going to say this. If no y-intercept used, then y minus y1 equals m times x minus x1. Okay, which is your point slope, right?
Yes.
But because we had the y-intercept, we could easily plug in y equals mx plus b. All right. Not yet. Does our scatter plot have positive or negative correlation?
They're positive.
It's a positive slope, so it's positive. So slope is positive. Okay. What is the slope? We just said it, right? It was 77 over 40.
30.
Okay. So explain the slope in this situation. Okay, hang on. So slope, I got to remind myself, is the change in the y over the change in the x, right? You know, yes, this is our slope equation, which is this. Okay. So our y direction is 77. Our x direction is 40. We said the y value was what? Up above, number 2? Snow depth?
35.
No, we just said what was the y, what was the dependent variable? And that was the snow inches. And then what was the x from above? Yeah, days. Starting at December 21st. Okay? Ooh. Yeesh. Okay. So ready? We are going to explain what the slope means in the context of this problem. We get 77 inches of snow in 40 days. That's what the slope means in the context. Good? Huh. I think that's okay so far. May I finish up? Hey, friends, make you a deal. If you let me end at 10:59 exactly, don't pack up, I will not assign anything for tonight.
Yes.
Deal?
No.
We got the deal?
Yes.
One person can goof it up. All right. All right. So what are the coordinates of the y-intercept? What did we say? Look up above on our thing. 0, comma what? 0, comma 35? Cool. All right. So what does the 0 mean in the context of this problem? Look at the very, very, very top line. 0 is what date? December 21st. Okay, so this is what the y-intercept means in the context. On December 21st, I guess 2014 is the year we're using, we had 35 inches of snow already. That doesn't mean we got 35 inches of snow that night. I mean, we've all seen our 14ers, right? Sometimes during the summer you look over at the Rockies, you see some white at the very top. We still got snow up there, agree?
Yes.
So not all the snow always melts, which it is what it is. Okay, so on December 21st, 2014, we had 35 inches already on this mountain peak. Okay. Oh, is everyone done there? All right. Hey, will somebody read me what was our equation that we had? Y equals what? Okay. So we're going to use this equation. So remember, this is the days, and this is snow inches. Okay? So it says use your equation to find the snowpack 25 days into winter. All right. Is days X or Y? It's X. So I'm going to take my equation and I'm going to plug it in. Oops. Can you reach in that cabinet and grab in that pink bucket, grab me a calculator, please? So this is times that you probably want a calculator. So things I'm going to do is I'm going to go I'm going to go 77 divided by 40, and I'm going to make it a decimal, okay? So 77 over 40 would be 1.925 times 25 plus 35, which means if I multiply that times 25, I get this. And then I add the 35 to that. So at 25 days into winter, we have 83.125 inches. This is what our model tells us. That's a good amount of snow up there, huh? Hey, is this exact? No, we're kind of using a model of our data to make a prediction. A prediction doesn't always be right. You ever watch the weather? Dave Aguilera on News 4 used to live down the street from me. I used to give him a hard time all the time going, dude, you got the best job in the world. You're always wrong and you still have a job. No, Chris, we have the scientific model to look at. And like, dude, you're always wrong. Just admit it.
How much do they even get paid? Just saying the weather.
I guess so. Maybe he studies something. Oh,
What type of study?
studies weather patterns and then makes a prediction.
You know what they said about-
Hey, can I move off this one? Okay, last question. So again, my equation was 77 over 40 x plus what? 35? So when will we have 100 inches? Okay, remember, this is the snow. This is the days. Okay? So I'm going to take 100, plug it in for y, and solve. Again, friends, this is where if you're sitting there without a calculator, make sure you do something with it. I mean, not this very minute because I'm walking through it with y'all. Okay, what did I do on that step? Converted the fraction to a decimal. And then solve it. Subtract 35. I want to get x by itself. So 100 minus 35, 65. How do I get x by itself? What do you think? Divide by this. So 65 divided by 1.925. So at 33.7 days into winter, we would have 100 inches. Friends, will you bring this back tomorrow? I will not give you an assignment tonight. Have a great day. Take care. Make sure if you owe me any tests or quizzes, we figure out when we're going to get those done because we're coming down. Thank you for getting this for me.